The second method, or third method, I guess, that we're going to talk about that helps with if we have a leading coefficient bigger than 1 for our trinomial is called the diamond method. And so here we have a different polynomial. It's 2x squared plus 11x plus 15. And the very first thing we're going to do is we're going to factor out any greatest common factor that they have. In this case, there is no greatest common factor, so it's just 1. And so that doesn't help us at all in moving forward in our factoring. So now we would move on, and we're going to draw a large diamond. I'm going to draw it down here because this is where I'm going to be using it. So in the next step, it says we're going to multiply the leading coefficient by the constant. You'll notice that this process seems already very similar to what we did in the box method, multiplying our leading coefficient, in this case 2 times 15, and we get 30. Now it says to place this product in the top quadrant of our diamond. And the coefficient of the x term is going to be what goes in the bottom part of our diamond. So that's going to be positive 11. The next step tells us to list all factors of the value found in step 3. So we're listing all factors of 30. And here there are quite a few to list out, so bear with me. So it's a positive number, so we could either have a positive times a positive, or we could have the product of two negatives. So we could have 1 times 30. We could have negative 1 times negative 30. We could have 3 times 10, negative 3 times negative 10. We could have 5 times 6. And we could have negative 5 times negative 6. We could have 2 times 15. And we could have negative 2 times negative 15. So here we have 1, 2, 3, 4, 5, 6, 7, 8 different possibilities here. And so in step 5, it says we're going to find the two factors. Again, we're going to call them n and m. So they're unknowns at this moment. In step 4, so those factors of 30, whose sum is equal to the value at the bottom of our diamond. So here, that's 11. So first off, let's find what those n and m will be. So let's add together all of our possible factor combinations. So 1 plus 30, we get 31. Negative 1 plus negative 30, we get negative 31. 3 plus 10 is 13. Negative 3 plus negative 10 is negative 13. 5 and 6, 11. Negative 5 and negative 6 is negative 11. 2 and 15 is 17. And negative 2 plus negative 15 is a negative 17. So again, remember that we're looking for which of them sums to be 11, and that is going to be 5 and 6. So again, in this case, it doesn't matter. You can call n 6 and you can call m 5. You can switch those around. Either way, it's going to work out to be the same. And it says to place these values in the left and right quadrants of the diamond. So let me redraw this. So we get 30, 11, and then I'm going to put 6 on the left and 5 on the right. Again, it doesn't matter if you swap those. And then it asks us to rewrite the original trinomial, replacing the x term with the sum n times x plus m times x. So we get 2x squared plus 6x plus 5x plus 11. And the next step asks us to factor by grouping. We're almost done here. So remember, when we factor by grouping, we are putting parentheses around the terms, two terms next to each other. So we have 2x squared plus 6x in parentheses and 5x plus 11 in parentheses. That's an equal sign there. All right, so remember when we factor by grouping, now we take each set of parentheses and we are factoring out the greatest common factor. So in this case, 2x squared and 6x are both divisible by 2x. So factoring that out, 2x times x gets us 2x squared, and 2x times 3 gets us 6x. And then in the second one, we have 5x plus 11. Oops, sorry, it shouldn't be 11. That is my fault. Our original polynomial was with our constant of 15. I apologize for that. So here we have 5x plus 15, and these have a 5 as their greatest common factor. So 5 times x gets us 5x, and 5 times positive 3 gets us 15. And notice here that we have our parentheses are the same thing, which, if you remember, when we factor by grouping, that always has to be the case. If it isn't, then we can't factor by grouping. And now the last step is to write these as factors. So we have, of course, our x plus 3. And then we also have these terms that are being multiplied by those factors. So 2x plus 5. And so there is our complete factorization of the polynomial 2x squared plus 11x plus 15. Again, be careful. You saw that I made that mistake. Make sure that when you are rewriting your original polynomial that it's plus whatever your constant was in your original polynomial and not what you had at the bottom of your diamond. So be careful of that. One thing I want to note is that the box method and diamond methods are essentially the same thing, but they just help us organize our information in different ways. So use whichever one you best understand and like to use. So all of these methods are useful tools for factoring trinomials, and you don't need to know them all. Like I said, make sure that whichever method you use, whether it be the diamond, the box, or the trial and error method, you are comfortable using it. Don't pick one that you don't like to use. So you can choose whichever you like best. I hope you find this video helpful and wish you luck as you are factoring your trinomials.